Hello everyone. Welcome to the functional demo of Calsoft's machine learning-based test impact analyzer. Here's the agenda. I'll do a brief walkthrough of the solution, and my colleague Sujit will do a functional demo of the tool. So here's the problem that we are trying to solve. So as products evolve with new features and workflows, the size of the test suite also increase. It becomes difficult to determine which test to include in the release. Random selection is not a viable approach because testing needs to have a significant impact on maintaining the quality of the product. And running entire test suite poses a risk of longer test cycles and potential delays in the go-to-market timelines. So some of the conventional approaches to do the test impact analysis are static code analysis, where developers give recommendations about, depending on the changes happened into an application, which are the most probable areas that have impacted. Then developer recommendations, even in many cases, developer also gives recommendations about the changes and the associated test cases to execute to validate those changes. Experience of QA is the most common approach because QAs have a vast knowledge of the product they are testing. So basically they can figure out which tests needs to be executed for which kind of changes. And in many cases, even the tests and the automated scripts are tagged or annotated so that depending on the changes, a specific set of test cases can be filtered and executed. However, the problem with all of these approaches is none of these are really scalable. So moment your test suites become tens of thousands of tests, these approaches doesn't even scale. So Calsoft is trying to solve this problem with an innovative and fresh approach. So we are using machine learning algorithms to validate and assess the changes going into the application, and depending on that, choosing which are the best and most impactful test cases to execute as part of the release validation. So here is how CalTIA works at a very high level. So like any machine learning algorithms, it requires data. So that data can be in the form of application maps, past commit logs, automated tests, any associated metadata information with the automated tests and historical test results. With all this information given to CalTIA's machine learning models, it then delivers the list of most impactful test cases to execute for a certain release. Of course, each layer of input improves the accuracy of the value CalTIA delivers. So talking about the feature roadmap, version 1.0 will primarily focus on recommending the most impactful tests. It supports GitHub, PyTest, and Jenkins as a toolset right now. However, that support will quickly grow with more tools CalTIA will support. In version 2.0, the tool will also have support for generative AI. So in this case, any missing test cases which needed to be executed to validate the changes, with the help of generative AI, the tool will be capable of creating these test cases in both documented as well as the code format. So we do have a MVP ready, and the version 1.0 will soon be ready in the month of January 2024. So talking about salient features of CalTIA, number one, it leverages various artifacts generated during the product development lifecycle. These artifacts include code commit logs, merge requests, test case reports, bug reports, test logs, and many more. The predictive test recommendation feature of CalTIA utilizes advanced machine learning algorithms to intelligently select and recommend the most impactful test cases for the optimal test coverage. CalTIA has a zero-touch workflow. What I mean by that is, after the initial configuration, CalTIA is supposed to be run in an autopilot mode without any manual intervention. CalTIA can be deployed as a container or on virtual machine, either of Windows or a Linux configuration, and can be seamlessly integrated with your DevOps pipeline. Executing the targeted subset of essential tests essentially reduce the infrastructure cost. So that's an additional benefit you receive when you use CalTIA. CalTIA's intuitive user interface lets you configure, manage, and monitor the tool effortlessly. CalTIA has a non-intrusive deployment. What I mean by that is whatever artifacts CalTIA leverages for its analysis, entire processing remains on-prem. It doesn't make any API call to the outside model. CalTIA's machine learning model is pre-trained with an extensive dataset of open source code commits. So it does have a robust context of what kind of artifacts it is expected to review and analyze to make the inferences. So here is how CalTIA looks when deployed in your CI pipeline. On the left-hand side, it has plugins for various different toolkits. It has basically plugin for GitHub, which is a code repository. It also has plugins for test management tools such as Jira X-Ray and TestRel. On the right-hand side, it connects with PyTest through the PyTest plugin. So any recommendations that CalTIA is getting, it will send it to PyTest for the execution. It also have a reinforced learning technique with which the recommendations given to the PyTest can be sent back to CalTIA depending on their validity and correctness. This helps CalTIA's machine learning model to improve its ability to recommend more appropriate test cases over the period of time. So talking about the deployment phases, there are 4 primarily. So when we deploy the CalTIA in any environment, the first phase is basically learning phase. Although CalTIA has a robust context of various different artifacts, it still needs to learn about your specific environment, product, and artifacts. So that is the primary objective of the learning phase. Once the learning phase is complete, CalTIA will create the blueprint of your application and the test cases. So it will essentially create the mappings and correlations between the tests and functions and components and all sorts of things. Once learning and blueprinting phases are complete, which we expect to last for 2 to 3 weeks, of course, depending on the size of an application, the inferencing will start, where CalTIA will actually start giving recommendations about the changes in that it is analyzing for the application. CalTIA will require periodic retraining. That depends on how volatile your application is. And that will actually help CalTIA to maintain the current context about the changes that are happening in your application, as well as the new test cases which are getting added in your test repository. We need to basically determine how frequently you will need that retraining phase, depending on how frequently your application and tests are changing. Now we will go into the functional demo. I will hand it over to Sujit to conduct the demo of CalTIA. Sujit, over to you.
Thanks, Shrish. Hello, everybody. Before I jump into the actual demo, let me just quickly show you the data that we are going to use for this particular demo. So this is a GitHub repository for an application called as Fast API, and it has all these multiple components. And within these components, then we have these Py files inside which we have the source code, and we are able to see all the changes that are happening to this source code. Also, along with that, we have the test cases that are associated with this application as well. If we go in any one of these components again, we see these specific Py files, and these have Py files have the test cases, specific test cases with respect to this particular component for this particular application. So what we are going to do here now is we are going to train this model in this particular demo itself on this repository, and we are going to try and predict test cases from these given test cases itself. So let me now switch to the CalTIA tool and quickly log in. Yeah. So this is the landing page, and this is where we have to do a one-time configuration of the entire tool, which will be the part of the setup, initial setup. So the first thing is we are going to provide the code repository. So currently we are supporting GitHub as the code repository, but we are in process of integrating it with others like Bitbucket and GitLab as well. Then comes the test automation framework. Currently, we support PyTest. And then is the CI/CD pipeline. So I'm going to choose Jenkins for this demo purpose as of now. Then the next thing here is we're going to provide since we have chosen PyTest, right? We're going to provide that PyTest configuration. That is the details of where the PyTest environment exists. So let me quickly provide those details. So this is the server address and the port number and password. Then comes the environment path, where the environment which is required for executing the test cases exists, along with the environment name as well. So that completes the PyTest configuration. Then this tool has the capability of integrating with the Jira as well. However, for this particular application, we do not have any Jira repository to track the defects or anything else. So that's why I'm going to skip it for this particular demo. Now come these two very important configuration setups. The first on the left hand side is the training configuration, or the place where we are going to provide access to the test case repository. So let me quickly provide access to these repositories. So this is basically the same repository that I just showed you all, wherein the test cases lie. And the tool is going to fetch data at various levels from the same repository and then help us to train the models. So this is the once I provide the access code, then this is the repository fast API, right? We have forked the actual repository so that we can use it for our demo, and this is what we are going to choose for this. And then once I do that, I can choose any of the branches that exist. I'm going to choose the master branch. And once I choose the branch, I can choose any of the folders wherein the test cases exist. So currently it is there in the folder called as tests. So I'm going to choose tests. Then this is where we can upload the requirements txt of the test environment if we need to create a test environment on our end, so that we can run the test cases. So I'm going to choose txt here. And then we also need to choose the Python version on which this test environment is built upon. So in this particular case, it is built on Python 3.8. So I'm going to choose Python 3.8. And then this is where we are going to provide the time range or the date range based on how far back we want to train our data on. So for the demo purpose, I'm just going to choose, say, from 1st November onwards until today. And yeah, so with that, we finished the training configuration. Now we come to the inference configuration. So this is where we are going to give details about the repository that we are actually going to track for any changes to the source code, and then based on that, recommend test cases. So in this case, as I showed you all earlier, the test cases as well as the source code both exist in the same repository. So I'm going to provide the same access details and get the same repository. However, the tool has the capability of syncing with multiple different repositories based on where your source code and test cases are hosted. So I'm going to choose the same repository again, as I said, and the same master branch. However, this time I'm going to choose this folder fast API, which is where the source code actually exists, and we want to track the changes that are happening to the source code. And these two are another two important parameters that we need to provide. The first one is the commit sync interval. This is basically the interval at which you would like to run these test cycles. This will depend upon how frequently you make changes to your specific application and how frequently you would like the tool to track the changes and then come up with test recommendations and run the test cases. So for this demo, I'm going to choose it to be a very small interval of 30 minutes. And the second one here is the model retrain interval. So this is so the models need to understand or get to know any new changes that are happening to your application at a regular interval. Say, for example, any new test cases are getting added or any existing test cases are getting modified. The model should learn that so that it can give accurate recommendations. So this is that interval which we are calling as model retrain interval. Here also I'm going to choose 30 minutes for now. So with that, we have finished the inference configuration as well. And if we go to the configure page, we see all the details that we have selected. Like for example, the code repository that you've chosen, the test framework, then the details of the test framework, the details of training repository, and the details of the inference repository as well. So with that, we finish the one-time configuration. And once we have done that, we can go to the Actions tab and click on Model Training. So once we click on that, what's happening now is the tool is accessing the repositories that we have provided, and it is trying to understand your specific application. All these models are already pre-trained on a large set of open source data. And having said that, the model needs to very specifically understand your application so that it can give very accurate predictions and recommendations. So right now what it is doing is it is fetching data in a read-only manner and trying to understand um, the nitty-gritties of your specific data, understanding the functional maps, the historical code commits that have happened, the PyTest logs that have been there for any of the older like historical test cycles that are there. And yeah, many such things, many metadata at various levels. In this case, it took a very short time because these models are already trained on this particular repository. However, when we actually deploy it in your environment, based on how large your application is, it might take a few hours to do this training. So once this is done, our models are trained and we are ready to get the recommendations. So once we come to the recommendations tab, we have uh, a setting to be chosen. One is by default, it is going to be in automated mode. By automated, what we mean is once we click on recommend and run test cases, it is going to go to the inference repository that we have provided. And it is going to check for any latest changes that have happened. And then accordingly suggest test cases and then run the test cases as well in one shot. However, when it comes to manual, there will be a couple of steps involved in it. This will basically give you a control on which test cases are to be run and which test cases you don't think should be run. So we'll come to the manual portion a little bit later. So for now, let me just stick to automated and click on recommend and run test cases. So once we do that, we see that the test cycle has already started, and we see a message saying that the test, you can see the results of the test cycles in the report and dashboard tab. However, this takes a little bit of time. So we can go to the dashboard tab in the meanwhile, and I can show you one of the previous cycles which have already been run. We'll get a notification once the current cycle is completed, and then I can switch back to the current cycle as well. So on top, if you see, we have a summary tab or summary card, and you see the number of test cycles that have been run thus far for the application and how many commits have been analyzed as part of these 48 cycles. And then also the average cycle time, which is around 170 seconds in this case. And then here we see the individual test cycles and details related to them. So as I said, 48 test cycles, right? So we have all the 48 test cycles listed in here. The time at which they were executed and the cycle time that it took. So maybe what I can do is I can take an example here of 47 cycle 43. I've clicked on cycle 43, and then you see a couple of graphics down here, these two donuts. So the first one shows you the number of changes that were associated with this cycle 43. There were 5 changes altogether, and they were distributed across 2 components. One is Open API, 4 out of them were in Open API, and 1 out of them was in security. So these are the changes that were analyzed in this particular cycle. And there were 341 test cases that were eventually recommended by the models. These were again distributed across 2 components. One was test tutorial, and the other one was others. So this is not part of any of the test components as such, so that we are categorizing it as others. And the graphic on the right over here will show you the actual impact that TIA would have. So without TIA, there are around 2,500 odd test cases in this application, the total number of test cases. So without TIA, we would have to run all the test cases. However, with TIA, if you see, and for the specific cycle 43 that we were looking at, we had to run only 341 test cases, which is corresponding to this same number. Of course, it varies from cycle to cycle, and it will vary depending on how extensive the changes are and how many changes are actually part of that particular cycle. So this is the dashboard tab, which will give you an overview about the different cycles. Then we can drill down a little bit more when we go to the reports tab. Let me choose the same cycle again over here, cycle number 43. And if you see here, we have multiple commits in here. And if I click on any one of these commits down here, we see the test cases that are associated or that were recommended by CalTIA. And we also see the test component in here, and then the test case name, and what is the result that we eventually got after we sent the test cases to PyTest, and PyTest returned the results to us. So we have all the test cases listed in here. If we click on another commit, then we have the test cases corresponding to that commit as well. So this will give you very specific information about which test cases were run and what was the result. Then this matrix tab will give you details about how the models have been performing. It is basically going to help you to evaluate the results of the model, the model results basically. So in this case, again, I'm choosing the same cycle. So if we see here, we have 4 blocks in here. And if we click on any of these blocks, we get these specific test cycles, the test names in here as well. So this is the must run box. So these are the test cases which the models have found to be directly related with the changes that have happened. So these are probably the ones which have a direct sort of a code linkage between the changes and the test cases. So these are a must run. Apart from that, there are these 95 test cases which are good to run. By that, what we mean is they don't probably have a direct code linkage between the changes that have happened and the test cases. However, based on what the models have observed, these are the test cases which would still get impacted, or these are the components which would still get impacted by the kind of changes that have happened. And this is based on the historical data analysis that the models have done. So for example, if there is any change happening on the API side, the UI and a particular UI part is going to get impacted, although there may not be a direct linkage. But then the models have realized that, okay, this is the particular portion of the UI that also needs to be checked and tested. And that's how it has come up with these 95 test cases. And then this third box in here, wherein these are the not recommended test cases. So these are the test cases which have nothing to do with the changes that have happened, and the models have not recommended them as well. So that's a very large chunk out of the 2,500, or we are saying around 2,100 plus test cases need not be run or are not relevant at all. And this one here is the red zone actually. And ideally, we wouldn't want to have any test cases in this particular area. This would mean that a particular test case should have been ideally recommended, but the models have failed to recommend that test case. That means a particular test case was relevant for the change that have happened, but the models have failed to recommend it. So in this case, we don't have anything in here, so that's the best case scenario for us. And if we have anything in here, we are in the recalibrate zone. So this is what we are going to then send back to our models to do a sort of a reinforcement learning, and the models would learn from these mistakes and become better and better over a period of time. So yeah, so with that, I think we have got the latest test case results as well, cycle 49. And this was the automated test case. Let me go back to the recommend tab, and now we can switch to the manual mode. So when we click on manual, it'll say that, okay, you'll have to wait for the current automated cycle to complete, because if it's in process, right, the automated cycle, it's going to, after the interval that we have provided of 30 minutes, it's going to keep on repeating itself, and it'll wait for that to finish and then switch to the manual mode. In this case, it has not yet started because we had given 30 minutes of interval. So it immediately switched. So now we are in the manual mode. And now when we click on the get recommendations, what the model is going to do is, it is very similar to the automated mode. It is going to go to the inference repository, check for any new changes that have happened, fetch those changes, analyze those changes with respect to multiple levels of data, as I mentioned initially, and provide those changes in the required format to the models. Then the individual models are going to run, and based on that, they are all going to provide results, which would then be consolidated, and a final recommendation list would be provided to us on this particular screen itself. And once that is done, we will get an option to choose the test cases that we would like to run. So in case of automated, all the recommended test cases were sent to PyTest to run the test cases and get the results. However, in this case, if we feel that we don't need to run all the test cases, we just need to run a portion of it, or a few out of those, then we get a chance to look at that in here. So this is going to take a couple of minutes. Once that is done, I will show you all how we can choose the test cases and then proceed to send it to PyTest. Yeah, so we have the recommendations from the models, and we have all these test cases. So basically, it shows the commit ID, commit message, and component, which is common across the test cases that are recommended for one particular commit. If there are multiple commits, you'll see the multiple commits in here as well. And then we have the test component and the test cases themselves. So we have all these test cases listed in here. What we can do here is, based on the experience the user has, the user can choose any of these test cases, right? So let me just choose the first 4 in here. And then if I select run test cases, so what the tool is going to do is, it is going to send only these 4 test cases that we chose to PyTest and get the results for them. In case of automated test cycle, all the test cases were getting sent. However, we get to choose the test cases in here, and also basically understand the recommendations that the models have provided beforehand, before even we run the test cases. So this will also help us to provide a feedback to the model eventually. This will also go in as a feedback based on the selections that the user does, right? So if you have recommended say 100 test cases, and out of which only 50 got sent to the PyTest, then the model would learn from it, and from like eventually over a period of time, it will understand that okay, only these 50 need to be recommended, and the rest of the 50 are not really required. So yeah, so with that, I think the test cases have been run. If we go to the dashboard, the cycle 51 is also in place over here now. And if you see here, there was one change and 62 test cases were part of that across two components. And yeah, so the manual cycle is also complete with that. So yeah, that's about the demo from my end.